Hello friends, good evening. Welcome back to our channel ALP Talks. This is your Lakshmipati. Today we have our guest Mr. Partha Sarathi with us. He is an electrical engineer. He is a Ph.D. holder in electric vehicle wireless charging related. So we had a very good discussion. We discussed so many things related to electric vehicles, energy transfer, wireless energy transfer, how we are transferring power and all. So what are the different method techniques are available? So some different challenges. What are the converters we will use? What is the process? Say we have our socket, we have our electric vehicle. So how we are converting socket to the electric vehicle? What are the process involved? What are the converters we will use? Rectifiers, inverters, cycloconverters. What are the frequency we will use? What are the different aspects are involved in this entire conversion process? What are the advantages? What are the disadvantages? What are the aspects related to all this industry? So batteries are there. So there will be so many issues while doing all these things. What is the power capability? What is the efficiencies? So many things we discussed it. Yeah. So this will be very good discussion for the people who are in research or who want to know about any advanced things in electrical engineering or who want to know about electric vehicles and all. So those people can watch this video till the end. They can get many more research topics also from our discussion, because Partha Sarathi delivered a very good lecture, good way we discussed it. There are so many different topics you can observe by going through our video. Those things you can choose as a project or a PhD topic for your career also. Thank you. Keep watch this video till the end. It will give good understanding to you. Hello. I am not able to hear you. Yeah. Hello.
Hi.
Hi,
Good
Partha
evening.
Sarathi. Yeah, good evening.
Good evening.
Yeah, welcome to our channel ALP Talks. Nice to see you.
Thank you.
Yeah,
Nice to see you as well.
yeah. First time I'm watching you directly. Very nice. Yeah, how are you? How things going on there in Vellore?
Yeah, everything is fine here.
Okay,
So,
good.
these things your side, everything is okay.
Yeah. It's good. Thank you. Thanks for accepting my invitation for this knowledge sharing. So I'm happy.
Welcome. Up. I'm
Yeah.
also happy to share something with you.
Yes,
It's
yes,
good
yes, yes.
for
Yes, yes, Partha.
interaction.
Yeah. Just to share a few things about me, just I'm electrical engineer. So I just started this channel for sharing the knowledge. So whatever electrical people are there in industry and academics, some research topic, something. So I am sharing some interview kind of things. So that's what I can say. It's benefiting many people. Yeah. So it's about your turn,
It's nice
path.
actually. I used to see your channel. I used to see your channel. So yeah, it's very informative and it's really helpful for people also.
Yeah.
Some basic fundamentals of the getting discussed and all the
Yeah.
very top subjects also you are
Yes.
discussing on your channel. So it is really very nice, and you
Yeah.
are
Thank you.
directly taking experts from the field. So it's very
Yes.
fruitful for researchers.
That's true. It's around
I used to see your
four
channel.
months old, this channel, but myself learning a lot from
Yeah,
everyone.
yes,
Yeah,
yes, yeah, definitely. It's
yeah.
really give and share things and all. So if you teach somebody something, you can get something also. So it's better. You're
Mhm.
doing a very good work.
Thank
Related to
you.
research community also.
Yeah. Very nice. Yeah, it's your turn, part. So let's speak few things about you, who are your educational and who you are. Then we will move to our topic: electric vehicles, wireless transfer, and all. Yeah.
Thank you. So I am Partha Sarathi. I have completed my PhD in VIT Vellore, and my topic was grid interface solar residential system with wireless electric vehicle battery charger.
Okay.
So during my PhD, I developed experimental prototypes and tested successfully the wireless power transfer technique to charge electric vehicle and all. So
Okay.
basically, it was very good experience to go to the electric vehicle sector as it is very popular in India right now.
Yes, yes,
And
yes.
wireless power transfer technique is really next level power transfer technique. So it was very nice experience.
Yes,
So
yes, yes.
definitely during this interaction, I am very hopeful that I'll be able to share some knowledge as well as I'll be saying something basic about these things also. So it will be very good. Thank you.
Okay.
Thank you,
Okay.
Amber.
Yeah, yeah, yeah. Hello.
Is it okay now?
Yeah, yes, yes, yes. It's okay. Yeah, it's okay. Yeah.
Okay.
Yes, Parth. So finally, you are a electrical PhD holder.
Yeah.
Yeah, good, good. Okay, okay. So we can. So your project, PhD project, whatever it is there, it is about wireless charging, right?
Yeah, wireless charging of electric vehicle.
Okay, okay, yeah. Can you speak a few things about this concept? I mean, what is the main funda? How you considered? I mean, how you got that thought of? Yeah, anyhow, e-vehicle is that is the boom in coming industry where power electronics and everything plays a
Yeah.
role. Yeah, you speak how you got that thought, how
So
you
first of
implemented and
all,
all. Yeah,
yeah, sure. So first of all, if you see, due to the pollution and due to petroleum products and all, so there are very much poisonous things, poisonous byproducts are getting generated and all.
yeah,
So we switched to electrical vehicles. So electric vehicles are they don't produce that much of pollution, and it is good for humanity as it is very smooth. There won't be any
so
sound and all will be generated. So it
yes,
is
yes, yes.
noiseless as well as noiseless as well as pollution free also. So
Yeah,
going for charging of the vehicle, as we know, when we start doing some project or when the research started itself, our main focus was for going for a automatic charging system, right? So
yes,
anything
yes, yes.
automatically done means it is helpful for
It is
humanity
good. Yes, yes,
or
yes.
it good for people. So people don't want to do more work, more tasks and all. So
That's true.
definitely, if you are going for a electric vehicle charging system, there are two types. So one will be plug-in vehicle charging, as well as another one will be wireless charging of the vehicle.
Yeah,
So if you'll see for the plug-in charging of vehicle, there must be a person all the time present to put the plug, to switch on, to do the task what should be done, what can be done, yeah, automatically if you are going for a wireless charging, right?
that's it.
So
That's
if you
it.
are putting a plug, this is off, and also if you are going for electric vehicle, the water is in water getting. So definitely if there will be any uh, rupture in the plug-in wire, or there is a rain and the water is there in your parking place. So if somebody is going to use that plug and maybe there somebody is going to use the plug, so definitely the user is going to get a shock. So
That's true.
basically the thing was to make the thing automatic as well as to make it safe for human being.
That's
So if
true.
we are going to compare between a plug-in and wireless charging of a vehicle, so wireless charging of the electric vehicle has these advantages, and gradual, and I can say why it is not here in market, whereas plug-in there in the market. If I compare between these two, in the starting of the research, wireless charging research, as their coils are loosely coupled, the charging happens by using two inductively coupled coils. So what happens? As you can see in a transformer, the two coils are coupled inside a core, in a common core. But in
Yeah,
wireless charging, the core will be different. So two separate coils will be coupled by inductive coupling. Two coils separately it will be coupled, and the core structure will be completely separately. They are not attached to each other. That will be so because of these things in the starting of the research, there was loss involved. So slowly what happened now, we developed the some basic techniques. There are
Okay.
techniques like
Mm-hmm.
compensation techniques. There are
Okay.
things like design of the structure of the coil. So these things we started doing. So
Okay. Okay.
now I can confirm you that there are companies like VIT, and there are researchers, very big researchers like University Auckland, two people are the JT boys and um, uh, I forgot JT boys, and
Yeah.
I forgot his name. So there are researchers in University of Auckland. So they are doing research, and if we go CRISME, also one researcher is there. So
Yeah. Yeah.
MIT also, they are doing so much research on wireless charging of electric vehicle. So
Yes.
you can see now the efficiency has gone to more than 95% of things.
Wow.
So which is basically
Quite
similar
good.
to the plug-in, similar to the plug-in charging of electric vehicle. If you'll
Okay.
see in the basic of efficiency, so definitely it is involving and it is improving, and
Okay.
it is.
Okay.
I can bet you that it is going to replace the plug-in charging of electric vehicle, because see, nobody should be there. You just go and park your vehicle, and your
Yeah.
vehicle will be charged automatically.
Okay.
You don't
Okay.
go there, you don't. And also one thing, one simple example I'll tell you. You
Mm-hmm.
have gone to some place, you have come from office and you are
Okay.
very tired, just you park your vehicle and went and slept. If it is a plug-in charge electric
We
vehicle and
have
you have
to
forgot to
keep.
charge it, and you have forgot to charge it, so next day how you are going to go to your office?
That's it. Nothing. We.
Nothing. Either you have to swap your battery, electric
Otherwise,
battery, what is there.
yeah.
Otherwise, some you have to use a petroleum vehicle, a
Yeah.
internal combustion engine vehicle.
It's
So
again
that is the
difficult.
thing.
Yeah. Yeah. Yeah.
It's difficult.
Yes.
Then and there to get a vehicle, and then and there to get a battery, it is really very big deal. So
Okay.
if you have a wireless charging of electric vehicle and you just go and park it and you went and slept, it will definitely, there is battery management system which
Okay.
will protect your battery from overcharging and discharging, and it
Okay.
will charge your bike. If the battery SOC is less, so definitely the charging will start automatically. You just,
Okay.
what you have to do, you just go and park your vehicle. That's it.
Yeah.
You don't have to bother about whether I have to be awake when it is going to be charged. I have to get plug it out,
No.
or
No. Yeah. Yes.
I
Yes.
have to go and plug it. So there is nothing. It's automatically getting connected and automatically getting charged. So next day you don't have to bother about your vehicle
It's
whether charge
all
will be there
always
or
it
not.
is full charge from when we get up in
Right.
the morning.
So
Yeah.
this is what our prime motive is, to make things automatic.
Okay. Okay.
That is our prime motive, right? So that's what it encouraged me to go for this area of research, wireless charging of electric vehicle.
Okay. Okay.
So basically, if you'll see, as electric vehicle is going to be future, and I am going to contribute something to it, like automatic, making it automatic charging. So definitely, it is going to be a very good
Yeah.
research area. So
Yes.
that's why
Yes.
I choose this research area basically. And
Yeah.
if I see the research environment, I have considered as residential home. So in the residential system, definitely, as slowly the transportation sector, if you'll see, in our residence we are going to use not only cars, there will be two wheelers like
That's
bicycle.
true.
So if
That's
we are
true.
going to involve in the future and everything is going to be electric vehicle, means definitely there should be automatic charging system for all. So
Yeah.
I developed a residential charging system. And
Okay.
as another thing we can see, if slowly all things are getting all the vehicles are becoming electrical, there will be additional load on the grid, right?
That's
So
true.
definitely we have to do something. We have to put a non-conventional energy sources.
Yeah.
So that what will happen now, the net energy taken from the grid will be reduced.
Yeah.
So what I did, I took primary system as primary source as a PV panel, a
Okay.
photovoltaic panel as a
Solar.
primary source. So what
Okay.
happened? solar solar charging. So the
Mm-hmm.
charge will be stored in if there is excess charge while doing charging of my vehicle, so excess charge will be fed to the grid.
Okay.
And
Okay.
if we are going to do a charging system where there will not be a solar in the present during the night, or there is a cloudy weather, and
Yeah.
my solar panel is not able to generate that much of power. So what will
Yeah.
happen that time? That time the solar will disconnected from the circuit and the vehicle will be charged from the grid. So
Okay.
these things, these power management things should be done automatically. So that was my basic research area. One thing
Yeah.
is electric vehicle charge automatically, as well as the load sharing or the power sources present in our residential system also should
Mm-hmm.
work automatically, so that that will be beneficial for the people. So
Yeah.
my full topic was grid interface solar residential system with wireless electric vehicle battery charger.
Yeah.
So there will be grid, there will be wireless charging of the vehicle, as well as there will be a primary source of PV panel will be used in the system. So
Yeah. Yeah.
definitely it was, I thought, what I hope is I have done some basic research to make something helpful for the human
Society.
being. So
Yes. Yes. Yes.
that
That's
was,
true.
yeah, for society,
Yeah,
definitely.
yeah, yeah. I have some few doubts here. Not that it's, for
Sure,
example,
sure, sure.
yeah, whatever wireless is there, one side, yeah, anyhow it is safer with respect because of plugs, wires, and are not there, short circuit and all. Yeah, the chances are very less. Loose plugging, arcing, those things are not involved now. With that aspect, we can say safer. But what about the waves and all masks? I am not sure
Yeah,
whether that will
yeah,
impact
that
or
point
not.
is also is correct. That is
Yeah,
called as radiation, irradiation.
yeah,
So
irradiation. Yeah.
radiation to the radiation exposure to human health or living being. So there is a standard for that. The
Mm-hmm.
limit is 3 megahertz, some
Okay.
kilohertz to megahertz level. So 3 megahertz. So
Okay.
if we are keeping, we researchers, we are keeping the radiation limit to that value, that
Mm-hmm.
frequency range. So definitely it is not going to affect the living beings around it. If
Okay.
something is there, if there is a necessity that we have to go surpass that frequency level, so at that time we need a barrier. So there
Okay.
will be
Okay.
aluminum foils, and there are different barriers
Shield,
also there around the wireless charging.
shielding we
So
have to use in that
yeah,
case.
shield. Yeah, definitely. Shield in that case, you have to use shield. So mostly we don't need mostly that megahertz rating, 3 megahertz rating, what I said, frequency range. In that, all the designs are possible nowadays with very good efficiency.
Okay.
When I am
Okay.
talking about good efficiency means the efficiency more than
Mm-hmm.
95% you can get.
Yeah, yeah, yeah. Okay,
So
okay.
yeah,
Yeah, generally the power socket and all, it will be around 50 head supply in most of the places.
yeah,
So
yeah,
whatever supply you are taking from the sockets, you are going to use with at a higher frequency for all this conversion process and all.
yeah. Yeah.
Okay.
So basic thing about the wireless charging is there will be coupled coils involved. That what I have already told you. So
Yes, yes,
what
yes.
happens is the size of the if we are going to increase the frequency value, the power transfer efficiency, power transfer frequency value, the size of the coil will reduce.
Yes,
That is
yes.
it's a normal thing in electrical, basic electricals.
That's true.
So what happens is if we are going to increase the frequency of our wireless power transfer circuit, so the size of the inductors will reduce. So there is a basic need that we need a high frequency power transfer. So what
Okay.
happens here? Our grid, the conventional grid, having a frequency of 50 hertz for
Yeah.
India, it
Mm.
is just 50 hertz. But if
Yes.
we are going to do a charging, wireless charging thing, and it need a kilohertz, let it be 50 kilohertz rating. So
Mm-hmm.
definitely we need a converter which can
Yeah.
convert this low frequency to high frequency. So for my
Yes.
work, I did a bidirectional cycloconverter. Why
Okay.
bidirectional? Na? I was
Mm-hmm.
feeding to grid as well as I was taking power
Reversing.
from the grid.
Yeah,
Yeah,
yeah.
so it was like G to V and V to G, both were working.
Okay,
So
okay,
grid to vehicle as well as vehicle to grid, both side power is flowing. So bidirectional cycle converter I took. So in
okay.
case if somebody want only feeding to the grid or only taking from the grid, just a normal cycle converter they can use.
Yes, yes,
Just we
yes.
need the
By the
frequency changing. Like yeah.
okay.
So as per the need of the researcher, they can choose whether it will be unidirectional or a bidirectional charger they need.
Yes, yes, yes. So you are using cycloconverter for making supply of, I mean, a very
Yeah,
high frequency. So that high
yeah.
frequency supply, say, what you are going to use that? I mean, how you are going to, are you going to give to inverter and make it DC or what? What is the process? I mean, what is your
First
plan?
thing is,
Yours is
yeah,
onboard charger or offboard charger? What is your configuration in this entire wireless charging
it's
concept?
a it's a onboard as well offer. Some part of the charger will
Yeah.
be present inside the vehicle also, and some
Okay.
part of the charger will be present in the charging station also. So it will be like that.
Okay.
So what happens is, if I am telling you,
Mm-hmm.
concentrating on the converter part, so
Mm-hmm.
while feeding from PV panel to the vehicle, so what happens
Okay.
is, my PV panel is generating a DC. So
DC.
I have to feed to vehicle. So I have to go for a wireless charging.
Yeah.
Wireless charging need a
High
high
frequency.
frequency power transfer. So
Yeah.
in that case, I have to use an inverter circuit. So to
Okay.
make DC generated by the PV panel to high frequency AC.
Yeah.
Okay, so that is a inverter part. So while
Okay.
going for the grid side, what happens is, mine is a low frequency AC which is present in the grid, but I
Hmm.
need a high frequency AC here in my wireless power transfer circuit. So
Yeah.
what I'll do, I'll put a cycloconverter there which can
Yeah.
convert a low frequency AC to high frequency AC. Then that
Okay.
high frequency AC will be transferred to the through the wireless power transfer coils. And in
Okay.
the vehicle side, what happens when in the receiver side also high frequency AC is getting received. So, but our battery, what electric
DC.
vehicle battery, that is a DC. So
Yeah.
again, a power conversion happens there. We have to use a rectifier.
Okay. Okay.
As a basic case, you can use a diode bridge rectifier, or if you
Yeah.
are going for any what you know uh, improved converter system, then improved rectifiers also available, which
Mm-hmm.
will which will transfer power very nicely to the DC battery. So
Yeah. Yeah.
these are the converter in the DC side, that is the we can use an inverter which will convert DC to high frequency AC, and in the grid side we can use a cycle converter which can convert the low frequency AC to the high frequency AC.
Okay.
That is the thing. These are the converter parts we can concentrate.
Yeah, yeah, yeah. Yeah, here I have one more thing. For example, whatever DC is there for battery, whatever DC is required, is this the only, I mean, if we use only off bridge, like what you said, the diode bridge, off bridge rectifier, or full bridge rectifier, or something, there are the different configurations. So, is the configuration matters whenever ripples are there in that DC, or it should be smooth DC for battery charge? Any idea on that aspect? I mean,
The
the
thing
rectifier
is,
aspect, yeah.
if you are going for a, yeah, in the rectifier aspect, if you are going,
Mm-hmm.
so if in the electrical, as a electrical engineer, if the ripple is very less, then it will be very helpful for us, right?
Yeah.
So we can
Okay.
use a filter.
Mm.
Generally, we can put a capacity filter, then
Yeah.
it will be a very clear DC at the output.
Yes. Yes.
Again,
Yes.
there, if we are going for a battery management system, because battery cannot be charged all the time, battery
Yes.
should be cut down when it is a when the SOC is reached, right? So what we will do, after the rectifier we can put a DC-DC converter. What will be
Okay.
the work of the DC-DC converter is, we have to use the DC-DC converter as the battery management system. So it will sense the some part of the, that is the DC electric vehicle battery, whatever we used, it will sense if the SOC is reached there, or if the charging current is reached there, or the terminal voltage, that is the voltage across the battery has reached this limit. That time it will cut down. So
Yeah.
all these things. So what we'll do, after the rectifier, we'll put a filter circuit, a capacity filter or something we can put, which will give you a clear voltage at the output, like the less ripple
Less
free voltage
ripple.
at the output of the rectifier.
Okay.
Yeah,
Okay.
less ripple. So that
Yeah.
ripple free voltage we can do need. We can go for a constant voltage, or we can go for a constant current charging of the electric vehicle battery. As per our need, it will do
Yeah.
the changes in the converter, that is a DC-DC converter whatever you use, and it will provide a proper power to the electric vehicle battery. So
Yeah.
this is what happens inside the vehicle. So I told you there will be some part of the converter also present in the vehicle, and some part of the converter also in the transition. So this is how it is.
Yeah, yeah, yeah. It's clear. It's clear. Yeah. So, for example, your whatever concept is there. for example, when vehicle is this for one substation concept or very low level concept? For example, household. Say if one house means we may have one car, one maybe any other wireless charging electronic devices. Maybe sometimes I'm not sure about the laptop. We have mobile phones, Apple mobile phones, and all. They will also need wireless charging. So shall we use those wireless charging for our devices also, or it is only for electric vehicle only, or what is your analogy on these cases? I mean, if I purchase one wireless charging setup in for my house, can I use for most of my equipments, or is there any compatibility issues? That's what I want to ask.
So Ambati, actually I have a very good story for this. Before few days, I saw a WhatsApp status that my friend put a WhatsApp status that I have to use separate charger for everything. My mobile phone, my trimmer, that is my beard trimmer, and for my wireless mouse, or for my laptop, for my everything. I need a separate. How many charger I am going to maintain? Like that one status, one guy kept, one of my friend, he kept. So this is what happens in plug-in chargers. Okay, Ambati. So that's what I am going to tell. Another advantages of wireless charging here. So what we will do, actually these things are evolving. So what we will do in the future, we are going to put a just simple barcode. We have to purchase a charger, wireless charger, and we have to put a barcode. So what that barcode will do, it will take how much, what is the device we are going to charge, what is the power rating of the device, and how much time it is required to charge the vehicle. So what will happen? Example, I'm going to charge my wireless mouse using that wireless charging dish. So what I'll do, I don't have to put a battery and all. I really don't like putting batteries again and again to the wireless mouse. That is a basic problem for everybody.
Yes,
so
that's
I'm
true.
going to use a pad, wireless charger. On that I'm going to use my mouse. So using itself, it is going to get charged, right? So for mouse, how much power I need? Very less space, right? So if I'm going to use the same pad for electric vehicle, it will just read the barcode. Whatever the barcode I have in the electric vehicle. So this is what type of vehicle, how much charge it is going to do. So how much charge it should supply to, how much charge it should transfer to the wireless mode. So those things. So simply, if I'll buy one charger, it will do all the work. It will do all the work. Just I have to do a sensor. I have to use a barcode sensor, which will sense what is my device is going to be charged, what will be its power rating and all. So using one charger, I can do all. But if you are going for electric vehicle, plug-in chargers, for my mobile, I need a C2 port or some Type C charger they are taking.
And for Apple,
then
different
for my
charger.
beard, I need a different.
That's
for
true.
Apple, different charger. For Android mobiles, different charger.
I mean,
So
sockets are
these
different.
problems.
Yeah.
Correct.
Okay.
So if we have a, it's actually developing. Some people I saw on internet also. Some people developing. There will be a universal charger, universal wireless charger. In using that, all the ways in my residential system is going to be charged. So that is the next level.
Yes.
Yeah, that is also a good concept actually, and the work is done on that.
Okay. Yeah, it's clear. So I have one more thing. For example, whenever like Wi-Fi range, there will be certain range for how much duration. I mean, how much distance it can give signal and all.
Distance of power transfer. Yeah.
Yeah. What is in this case that situation? Can you discuss?
So basically, if you will see, now we are concentrating on the distance between the ground level and the chassis of the vehicle, car or bus. That will be within some meters. So based on the so they.
Yeah, your voice is breaking, Parth. Yes, proceed. So,
so while talking about the charging between the coils, so different depend on the devices what we are going to charge, we can vary the working of the inverter, working of the power supply, working of the frequency of the converter. So all these things can be done. There will be automatic chargers, what
Okay.
that they can do all this part of the work. So charging will be smooth.
Okay, okay. Yeah, for example, like a dining table, whatever we will eat in the house, everything we will keep on dining table, everyone will surrounding eat it, right? Like that, if we have one receiver somewhere in the house, everyone, shall we use like that? I mean, whatever the devices, everything we have, shall we use like that? What you say on that?
I think.
Yeah, 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 yeah. Okay, okay.
So we
So
can proceed to the next question.
yeah, yeah, yeah. So whatever I'm asking is, so if we purchase one wireless charging circuit, is everyone in the house we can use it, right? Like whatever you told
Yes,
earlier. Okay,
yes,
okay.
yes, yes.
Yeah, is the this for example, say for Apple phone charging and all, we need to place our mobile phone on some pad. At least
Yes,
some distance they may allow 1 inch something like that. Is that situation is
yes.
mandatory or it's not required? Like light, it can be somewhere. The circuit can be somewhere like Wi-Fi. Can we use this electricity? I mean,
No,
more
no,
this.
no, no.
No.
Till that much distance we have not developed. Actually, there is microwave power transfer technique that is
Mm-hmm.
called as MPT in short. So
Mm-hmm.
in that larger distance, like from the earth to even space also we can transfer power. There
Okay.
are technique wireless part, but what is the basic problem is if there will be any obstacle will come in between, and there
Mm-hmm.
will be any irradiation device present inside in between the carrier charge
Mm-hmm.
carrying path, so that
Mm-hmm.
will be, there will be a problem in that power
Okay.
transfer, so efficiency will reduce or something, some problem will happen. So that's why we cannot transfer that much distance as of now, but we can do like what I told you, from the ground level to the chassis of the vehicle. That is how much
Okay.
distance it will be, around some meters it will be. So within that range we can do the power transfer now. Even
Okay.
what you told, like transferring to the bulbs, what is the light electric bulbs are present in the, so that thing is under development. I can say
Okay.
that one.
Oh,
So
okay.
that much distance we have not achieved yet.
Okay. Okay. Yeah. One more thing is
Yes.
like sharing Wi-Fi concept is there. I mean, sharing Wi-Fi.
Yes, yes.
Yo, in that manner, how it is this charging concept, wireless charging concept, sharing
Yeah,
and all.
so that we can say about that is there is a term like we can lock it, like there will be a barcode or specific some sensor will be there which will
Mm-hmm.
sense so that the network will work. Like if you have not paid and you are going to park on my charging pad, so you are not paying for that electricity, right? But you are going, you just gone and you have gone there and just charge just kept you just parked your vehicle there. So it should not transfer the power, right? As you have not paid, so you should not be getting that wi-fi, getting that power transfer thing.
Yeah.
So that's why there will be a scanner, there will be a code scanner, or there will be a sensor which will sense my, yeah, this belongs to me, so the charging or charging part will start. If it is do not belongs to me, it should not charge. So that thing
Okay.
also there. So
Okay. Okay.
for enabling thing, that scanner, code scanner or barcode scanner, there should
Okay.
be a sensor.
Okay, okay. Yeah, I'm using here. I have another thing. For
Yes,
example, I purchased one setup for my electric car for charging
yes,
wireless charging. Say, for example, my neighbor has some, for example, two-wheeler. So
yes,
two-wheeler with wireless charging receiving capability is there. So,
yes.
shall we use any booster kind of thing? For example, if you see any dish wire in our local, they will use some boosters for boosting the voltage or boosting the signal, something like that.
Yeah, yeah,
Shall
yeah.
we place small
Yes, yes,
boosters so that we can transfer to others? Say I am sitting in my one room bedroom. I need my charging for my
yes,
mobile iPhone. So you told as per our conversation, we need some pad and then we have to keep it some
yes, yes,
stations, some
yes,
station, something like that. So say my child need charging for his phone. So
Yes.
how what is the thing? Again, there should not be any plug-in, right? He also
Yeah,
should be
correct.
able to receive. So
Correct.
is that possible or anything?
So yeah, for that it is also there is a term like multi-coil power transfer technology.
Okay,
So there
okay,
will
yeah.
be a single coil in the primary side which is connected to the source, power transferring source, and there will be multiple receivers will be there. So
Yeah,
that
yeah.
technique also started. There are
Okay,
research papers, there are research
okay,
articles. So
okay,
that is
okay,
called as multi-coil charging system.
okay,
So
okay.
what happens in that? There will be a coil, primary side coils, and there will be multiple secondary side coils which are connected to the loads. So in that way, we can transfer to the multiple loads. Like you are saying in your home, there are two, three loads,
Receivers.
devices are there to be charged, equipments are there to be charged. So
Mm-hmm.
definitely, yeah, it is also possible using wireless charging technology.
Okay, okay, yeah. Okay, one more thing. What is the capacity? For example, we have terminology like a 250 kilowatt or something like that.
Yeah,
Some kilowatt range will be there for each electric
yeah, yeah.
vehicle or the loading. So, what is the capacity you considered for this case for wireless transfer, whatever the model you did?
So what
Generally,
happens is if you are
mhm.
going for a small device like charging a mouse and all, there will be just few wattage ratings.
Yes, yes,
And
yes.
if you're going for two wheelers, there will be a like kilowatt rating, like within the 10 kilowatt rating, we can
Yes,
design a charger. If you're going a four-wheeler vehicle or a truck or a electric bus,
hundreds of kilowatt.
definitely, yeah, yeah.
Okay, okay. I mean, if you are going for hundreds of kilowatts, is there any limitation for the transfer of charging or?
Yeah, limitation what we can say is charging time may increase. That's what I
Mhm.
can tell. So
Okay,
if
okay.
I am going to do a charging part of a very big kilowatt rating load, and I have a like limitation of charging wire, charging cables, sorry, the wire which is there in the charging station, and also the size of the inductors that is used in the charging. So the thickness also will be increasing, right? So if you are transferring more powers, or it is a larger charger, a larger wattage rating charger, so definitely the thickness of the wire used, or the to make the inductor, the laminated copper wire or something we are using, so the thickness also is going to increase. So if the thickness is going to increase, the weight of the inductor that is used, that is also going to
Everything
increase.
increases.
So all these things also there is a limitation, like this much wattage we can go. So based on the limitation, based on the power rating, if the load is big, so charging time is going to increase. That's it. Other things will be normal. So only
Yeah.
there will be a change in the charging time. We can, if you are going to do a boost charging for example, I have a 30 kilowatt power transfer. I have a 5 kilowatt something. So 5 kilowatt charger. So it is going to take charging uh, based on that. So all these
Okay.
things is going to involve in that.
Okay.
So as per our necessity of the load, we have to choose our inductors. Okay.
Yeah, yeah, yeah.
So
Yes, we are discussing so many topics, interesting
yeah,
things.
yeah, yeah.
Nice,
Sure,
nice,
sure,
nice.
sure.
Yeah, so what about dynamic charging? Whatever you discussed till now, it seems static charging. I mean, the receiver will be static. I mean, static means little bit
Yeah.
movement, that's okay. Little, just
Yes.
here and there,
Yes.
little bit. And
Yeah.
the sender is almost
Actually,
stationary.
I can say
Mhm.
what we discussed. Yeah.
Yeah,
Yeah. Yeah.
yeah. Tell me, proceed.
So I can say what we have discussed till now, it's a stationary charging.
Yes, yes,
If you
yes.
are going for a dynamic charging of vehicle,
Mm-hmm.
at that time there should be a sensor involved. So and also the charging path, that the path where vehicle will go, the road pathway, there will be multiple coils should be placed in the pathway. So when
Yeah,
the
yeah.
vehicle starts moving on that, so each one by one charging coils will be sensed. Then the power transfer will happen. So at that time what happens, uh, there will be a small charge, you can say it's a charging packet.
Okay,
Like
okay.
here, if my vehicle is moving, so till here 5% SOC, 2% SOC, 1% SOC. If you are
Number of
divide, so number of coils it is going to move. So the little the battery will be charged little, and it will be discharged as well as
yes,
it is
yes,
moving. So
yes, yes,
charging and discharging both is happening, and
yes, yes,
the
yes,
beneficial is here. The battery size will reduce. We don't need to charge it fully when starting the journey, right?
yes, yes,
So
yes.
battery size is going to reduce. If battery size is going to reduce, so the weight of the overall vehicle is going to reduce, and it is going to show us better mileage, we can say.
Yes.
It will cover
Okay.
a big distance.
Yes, yes,
So
yes, yes.
dynamic charging is the next level concept
Yeah,
of the
yeah,
static charging.
yeah,
So these
yeah.
things are involving
Yes, yes.
as from, yeah. Thank you.
Here I have one more thing. For example, in dynamic charging, both charging and discharging happening at the same time.
Yes,
Discharging may be happening more rate, charging may be happening little bit less rate. So,
yes,
is the batteries are capable to do so? Whatever existing technology or existing batteries are there, is it okay? For example, in house itself, when we
so
have an inverter backup, whenever power is not there, it is coming. That the battery power we are
yes,
using, and
yes,
power is there means battery charging, something like that. At a time,
yes,
only one action is mostly we are doing. I don't know
yes,
whether both will happen at a time or not. But here we are doing both action, charging and discharging simultaneously at the same time will happen for the particular battery. Only both side flow is there. If
yes,
we are getting more flow means vehicle is moving very slow, it needs less power,
yes,
and charging
yes,
more means it will go into the battery. The vehicle is
yes,
moving very fast, some more power is required for the tractive effort, then power is coming out of the battery, even though it is coming from the charging from the
yes,
bottom, we can say. So what
yes.
is it? Do you have any idea on these aspects? Is
Huh.
any?
Yeah, it is, Ambati, it is a new research area. It
Mm-hmm.
is on storage, charge storing elements research area. So in
Okay,
that
okay.
what happens, now we have lithium ion batteries in our mobile phone.
Yes.
So what it does, while charging also, sometimes we use our mobile phone also. If there is an urgent call, urgent messaging or something is going on, so definitely we are going to use lithium ion battery. So lithium ion battery is capable of doing both charging and discharging
Same rate,
at
same
a
time.
time. So
Mm-hmm.
yeah, in the same time it is going to do the charging and discharging part. Also, there are there are some technologies coming like iron oxide batteries are coming.
Okay,
So
okay,
different
okay,
iron
okay,
oxide, new things. So iron oxide is has taken the lead, we can say. So
okay,
again,
okay.
going for the charging and discharging thing, new super capacitors are getting, ultra capacitor as well as super capacitors also getting. Uh, that is a new research area. So those
Okay,
research
okay,
things
okay.
are also going on for
Yeah,
the charge storing element. So you
yeah,
can
yeah.
say now new headlines has come that Reliance is going to design a new battery for India. So that is the thing coming for
Yeah.
charge storing elements.
Okay, very
So that
nice.
is also a research area we are concentrating on. So see, we can see here there is battery management system also going on. There is research area on development of new battery also going on. There is research on developing of the power transferring coils also going on. So it is a very huge research area.
Got
What I
it.
can say to the research community, it is a very big research area. We can concentrate
You,
on any part. It's a
yes,
very
yes.
huge, and it is upcoming, and it is going to be very advant very it is going to give us very so many advantages to the uh,
Community.
uh, generation, society, community. So
Yes, yes.
those things I can say. So they should be very interested, people should be very interested, and there should be more funding from the government also.
Yeah, yeah, yeah.
So that's what I can say.
Yes, yes, yes. Yeah, Partha, since yeah, our discussion will keep on going. This so many topics we have,
Yeah,
so we can't
yeah,
continue.
yeah.
Yeah, we are going to make many more small videos in the coming future also.
Sure, sure,
Yeah,
Ahmed, you are welcome.
for today, for example, if anyone who is interested in a electric vehicle or this battery or these challenges, so what things you can suggest to your any MTech or PhD students who are there? What suggestion you can give to them about this area?
I
Yeah.
will say, I told you so many parts are there. One is power electronics converter part. You can develop new converters which will reduce the loss. You can develop new power transferring coils which will transfer power for a larger distance.
Okay.
For a larger spacing between the coils, it can transfer power. You can develop the new battery management system for battery charging and discharging management.
Okay.
So you can go concentrate on the battery manufacturing also, like what are the products required, like different coils, different battery structures, what is there. Or else you can concentrate on the new things like supercapacitor. Battery is not the only thing. You can consider on the supercapacitor, ultra capacitor implementation to the electric vehicle. So these are the area. One is power electronics area, converter inverter. One is a coil area you can consider. One is battery management system area. Another one is the manufacturing of the battery area. So there
Yeah.
are huge opportunity and huge research area is there.
Yeah.
So all
Yeah.
these things also a new researcher can concentrate on any of this. So it
Yes.
will be
Yes.
very
Yes.
good.
Yeah, yeah, yeah. Sure, sure, sure. Thank you, Parth. You have so many things I want to discuss with you on this platform. Yeah, you have some
Thank
patents.
you.
You made some conferences, some journals, and you did some major projects. Around 5 6 projects are there in this power electronics and renewable and this wireless area. So you have some experience also in so many topics are there. I will have some route map. So what are the things we are going to discuss in future? As it is first session, so we discussed so many topics. Whatever thoughts or things are coming in my mind, we discussed it. Yeah, in future, in a disciplinary way, small topics we will take and we will discuss it. It's
Sure, sure.
very nice. Thank you.
So
Thanks a
thank
lot. Our discussion, I hope,
you.
will give some triggering to many engineers who are working in
Sure.
electrical industry. Thanks, dear. Bye. Thanks for your time.
Thank you, Ambali. Thank you.
Yeah,
Bye.
yeah. Yeah, this is about wireless transfer, guys. This is not the end, as I said in the video. This is just a starting with me and Partha Sarathi. We are going to do many more topics in the future. He is working in VIT. He has some good exposure. He delivered it. I hope you enjoyed this content. If you have any questions or comments or anything, then please comment in comment section. I am ready to make things clear. If you are watching this video for the first time, please subscribe to this channel so that I don't miss any of the future updates. Whenever I am posting any video, you will get immediate notification, then you can watch it. Yeah, if you want to be a member or if you want to share your knowledge in this channel, then you are always welcome. Please comment us. My contact details are available in the video description. You can just message me. I am ready to take your knowledge and all and share on this platform. It will helpful to many people. Thank you. Thanks, guys. We will meet in next video. Bye. Take care.